During the 19th century, it was said that substances only absorb or emitted certain amounts of energy. This discontinuous spectrum couldn't be justified with the classical physics. The electromagnetic spectrum is a continuous spectrum because it contains all types of radiation. Normally, we represent the visible range, which is what we can see. Atomic spectrum is a discrete spectrum that contains information about the radiation emitted or absorbed by a substance and which, being unique, is equivalent to its fingerprint. But how is this spectrum justified? In Bohr's atomic model, electrons rotate around the nucleus in stationary orbits. These orbits are quantized, their energy remains fixed. And the most important fact is that an electron can jump from one orbit to another. This is like us when we climb the stairs. We can stay in the middle of one step because the electrons will only be able to absorb and emit energy in the exact amount that they will need to go to the next level. When an atom absorbs energy, it is spending electronic transitions from lower levels to higher levels, thus giving rise to excited states. When the electrons return to the fundamental levels, they emit energy in the form of light. These amounts of energy that the electrons absorb or emit must be exact. In fact, they depend on the substance, and that is why a spectrum is considered its fingerprint. Scientists use this spectra to determine the elements that make up substances and the bonds they have to each other.